Hello friends, hope all is well. In this video we are going to build our first Interstellar level video game right now, right here, live. By the way, this is the beginner's video with an idea of introducing to the world of game dev. This video will enable you to take your first baby step towards producing an ultra photorealistic video games and simulate the reality to an astonishing level that you can ever imagine. You'll be able to publish your games to consoles like PlayStation, Xbox, or Nintendo, or even other mobile platforms like Android and iOS for the. Before we get in, a quick trivia. Do you know that the gaming is a $150 billion industry, making it bigger than a movie and a music industry combined together, with 2 billion gamers around the world. We are talking about the number one industry in the field of entertainment. Taking that as a bit of inspiration and motivation, let's jump right into the development. I'm going to use a couple of softwares, Unity as my primary game dev engine, and Visual Studio to drive some behaviors, to do some bit of coding and stuff like that. So let's get into action. So you can always download Unity by yourself, follow through the links and follow through the guidelines, and you'll be all set to go. And of course, ensure you have a Visual Studio installed too. So let's get into the development. So I have the software already installed. This is my hub. I'm going to develop a new project. So I'm going to click on this option. I'm going to develop a 3D game. So let me give an Interstellar. Okay. Choose a location where you want the project folder to be in. So as soon as you create a new project, this is the default layout. I'm not going to give you a complete tour to Unity, but I'll give you a basic insights of what this software is all about. On your left, you see a project explorer. So you have all your game scenes, and whatever the objects that you have within each of the scene is arranged here. You have some of your asset panels we'll talk about as we go by. Some of your consoles, just to check, how your programming is going on. You want to do a quick print and stuff like that. Here you have your property window for each object. It show you several characteristics that you can customize it. And of course we have lighting and whole lot of things, the menu panels and stuff like that. So what I'm going to do right now is do a simple thing, and of course here is a gizmos that tells you how this appears in your world. And if you see here, there are multiple tabs here. So this is the design view, what we can call it, and this is the play mode. So when you play the game, this is how the camera sees the world. So what we will do is we'll create a quick game object. For example, let me create a quick cube. And of course, always when you create a new object, doesn't go to the center of the world. You need to reset sometimes. So this is the origin of the world as we see it. Let me make this object twice the size. So let it be Y, and in this direct I will make it again 2 units. These units are not the real world units like the kilometers or meters and stuff like that. We'll talk about those things later in the day, but for now you just assume they represent 1 unit of measure right now. What we are trying to build is a simple rocket game, trying to move from point A to point B. And of course, there will be obstacles coming in, and how the rocket maneuvers through those obstacles and eventually reach the destination. So that's the core game mechanic that we are trying to build. But let me say, this is my launch pad. Okay, so I just named that object as a launch pad. So let me create a ground plane again, create 3D object, again create it, and of course you need to reset it to the size. Let me say this is 100 units wide, and I want this to be 30 units taller, and again let's say this is 100 or maybe 50 units into the depth. Yeah, So let me call this as terrain. Okay, so if I just make it 15, yeah, okay, so this is my ground plane level. So here is my object. So my launch pad is all set. Let me create some material so that you can visually differentiate what they are. Okay, I'm creating some base materials. I'm just going to give some earthly texture of deep brown. Okay, let me duplicate that and create one more launch pad. Let me give a different color. The launch pad, let's say I want to make it a bit more metallic so that it is a bit more darker. So I'm going to drag this. Okay, okay, cool. So if I press this, I'm in the game mode, and let's see what the camera looks like. So this is what the camera is looking right now. You can play a game using a shortcut key, Command P in Mac and Control P in PC. So the system is in the run mode. You see the other areas gets darkened and your play area gets a visible real estate. So you have a ground plane, you have your launch pad. I exit by pressing the button again, or again pressing the Command P or Control P in your system. Next, what we will do is I will create this time not a cube but something called empty object. The empty object is more like a parent object, which is the container. So let me call this object as rocket. Now I'm going to create child objects. So this time I will create a cube. Let me call this as rocket body. And of course I'm going to reset its position, and let me reset my rocket as well so that everything is in place. Okay, so I want my rocket body to scale in y-axis a little taller. Okay, so let me say 5. Okay, let me duplicate this. Okay, let me duplicate this. I'm going to call it rocket nose. Yeah, I'm going to keep it. Let me create another material for rocket. Let me give a blue shade. Assign to the rocket top. So let me create one more. Let me make it dark gray. Okay. Let me add a couple of boosters. So let me copy this. Let me move. Let me reduce the scale as well. Control D. select both. Okay, we built our first rocket. So as you see, this is just a primitive design. I'm using a primitive objects to build a rocket. But what we will really do is, we will use softwares like Maya or 3D Max to really do a character design, the object design in 3D, and we'll do a proper texturing, and then we'll import into the Unity to build our game. Okay, so we have our rocket standing on our launch pad. Now what we need to do is we want this rocket to be moved. Yeah, we want the rocket to fly up, we want the rocket to rotate and change direction and move in that direction. So how are we going to do that? So what Unity offers is something called game physics engine. It's leveraged through an object called rigid body. So I'm just going to add the rigid body game physics aspects to this rocket object. See, it already comes with a mass and a drag, the air viscosity and all that stuff. So we'll talk about more in detail a little later. But let me just show you a demo of what this can do. So I'm just going to keep the rocket up. I'm going to play the game. The gravity is naturally going to pull the rocket down. Did you see that it coming down? So I'm just going to play again. The rocket is in the air. It automatically comes back because of the gravity and based on the mass of the object in context. See, here it is 1 unit. So what we are going to do right now is I'll put it back in my world. Let's fly the rocket. So how are we going to do? We added a rigid body object here. Now we need to add some code to it. So what I'm going to do is I'm going to add my first code. I'm just going to add a script called rocket controller. I added my first rocket controller. So when you launch, you see, the Unity game engine is imported. That's the library that I'm using. We'll talk about all these things a bit later. And let's do a quick print to check whether it's all okay. Yep, just going to save it, go back and play the game. And let me just show you in the console before I run. So I run the application. If you see here, the application is started. I have message staring, okay. And then you see all my update messages kept firing. So depending on the frame rate of your computer or the device that you play the game, it varies, so the updates keeps firing. Yeah. That's the basic nuance. Now what we need is, okay, I want to control the rocket. When I press a tab key, I want to thrust the rocket and push it up, and use my left and right arrow keys to move the rocket left and right. Yeah, so that's what I want to do. So what I'm going to do is a simple if input dot get key code dot space. Yep, I want to say, let's say first space thrusting. Yeah, I'm going to say if input dot get key code dot left arrow. I'm going to say print turning left. Yeah. So if the key pressed is the space bar, I say thrusting. If the left arrow is pressed, I want to say left. Otherwise, I want to say right. This input object is an abstraction of several device, keyboards. In a PC-based app, we use a keyboard. If it is mobile, then we have a different key models. If it is the console driven, then that has its own infrastructure. What Unity provides is an abstraction to all those device inputs or the user input. So that's what we're trying to do. So let me save it, go back and run the app, and before that let me just clear the console, print. Oops, it happened. Okay, so it's showing me some error. What did I do? No, all's okay. Oops, sorry. So starting now, I press the tab. Yeah, I press the space bar. Sorry, I'm getting thrusting. I'm pressing my left, so I'm getting turning left. I'm pressing right. It's getting my right message. Left, right, space, left, right, space, right, left. Yep, okay. So the system is able to recognize my commands. So now what we need to do is when a space is pressed, I want to thrust the rocket up. So how am I going to do it? So we added a games physics object called rigid body to this rocket. Now I want my script to access this particular object, a sub object, the rigid body, so that I can use its properties to push the rocket up. How am I going to access from the script to a rigid body? So let me have rigid body RB. Okay, so what I'm going to do is I'm going to get an access to that object, by using get component. There are different overloaded methods out here, so what I'm going to use it is this particular type because I want to typecast and get my rigid body object from my rocket. So I have an RB now. Now what I want is I want RB dot, what should I do? I want to say I want to add a relative force, okay, and I want to say it takes vector 3, okay, and I want to say I want to push the rocket up. Okay, so vector 3 is a 3-dimensional object. So if you see here, position, rotation, scale, they're all of type vector 3 because it has got the x, y, and z aspects to that particular object. So RB dot, so let's see whether we are able to push the rocket up with this simple line of code. So I'm going back, Control P. I'm thrusting, but the rocket is not moving up. The only reason could be the mass is too heavy, and the relative force is not good enough. So let me say 0.001 just to do a testing. If you see, I'm able to control these properties in the run mode, but when you exit the game, all these properties would be lost. Just be aware of that. So now I'm again pressing oops. Okay, so did you see it just went somewhere? So let me just give 0.1. Just going to play the game again. Okay, so I'm going to say drag is 0.2. Okay, cool. So now we are able to make the rocket move, and the natural mass is pulling based on its gravity force and angular drag and all that stuff. Okay, so let me set it to 0.2. Okay, Fine. Now we need to rotate the rocket. So what I'm going to do is go back to the code. So what I need to do, so this time I want to rotate the object, which means I need to access this particular property of a transform object, just like how we access the rigid body. The only difference being the transform and rigid body is, every object that you create inside Unity will have the transform object, but all these other objects are what the game developer will add explicitly. Because every object has a transform object, naturally Unity doesn't need you to get an access to that particular component before accessing it. You can straight away access it. For example, I can straight away say transform dot rotate. Again, it's going to take a vector 3. This time I'm going to say forward. Okay, so to make it right, to turn right, all I need to say is minus. Let's see how it works. Okay, it's going up, it's going left, it's going right. Yeah. Okay, so I'm able to move my rocket, but the only thing is it's going all around the place. So what I'm going to do is do a minor control. If you see here, the rigid body have got something called constraint. What I want is I want it to freeze its position in the z-axis, and I want the rotation to be frozen in the x and y, which means I'll have more control and I will be able to navigate my rocket in one particular motion. So let's see how it happens. Okay, up, down, up, down, up, down. Okay, so now I'm able to move my rocket. Okay, cool. The only thing that I need to do is, because I'm also controlling, I'm not allowing the game physics engine to take control of it. So what I'm going to do is, I'm just going to say rigid body dot freeze rotation equal true. Once all is done, yeah, so I'm just taking manual control of the physics engine. I do my bit. Once I'm done, I'm releasing the control back to the physics engine. So that's what this particular piece of code is doing. Let's see how it behaves now. Okay, cool. It's much more controlled. I can land. Yes. Yeah. Okay, cool. Okay, I'm able to fly my rocket the way I want. So, but the thrust and the rotation is not good enough, so I'm just going to add a couple more properties. I'm just going to say, we'll talk about what the serialized field is all about. Okay, I'm going to have RCS again 100. Okay, so that's the rotation thrust. Okay, so just if you want to know what is RCS, how RCS looks like. Yeah, so the reaction control system, and if I go here, you see this is the thruster we are trying to describe its behavior, and which is instrumental in rotating the rocket smoothly with the appropriate thrust levels. Yeah. So we created a serialized property. So what the serialized means is, now I can control those two properties, during my runtime. So I can set different values and see how quick, how slow, how much drag I have while rotating. All that stuff I can control during the gameplay. So that's why I introduced this rather than every time having to switch to the Visual Studio. So that's what the serialize field helps you to do. You can control some of the properties during the runtime just to simulate various aspects of your gameplay. So having done this, now what I'm going to do is I'm going to my main thrust. I'm just going to, I want to call main thrust, not thrust. And I want my left arrow, I want my left and right rotation to be based on my RCS value. Yep. Oops, 100 is too heavy. Yeah, so let me say 10 and let me say 250. Yep. Okay, let me reset the mass to 1. I think mass is too low. Yeah, okay. Oops. See how nimble my rocket can rotate. So if I say 150. Okay. So I can say 50. Okay, one thing that we need to do is the frame rate is too heavy and that's why it's rotating the way it is right now. So what we need is RCS equals time dot delta time. Sorry. I will say what I'm doing. There is a concept called frame independence. What that means is, every movement of your object, responds differently based on your clock speed of your computer, the frame rates that it renders and stuff like that. So it's always important that you convert them into a frame independent movement. So what I'm trying to do is, if you see here, I create the time dot delta time is the one which Unity helps to give that abstraction. So I'm just multiplying my reaction control systems by the time independent factor, and that gives you a float rate, float value, and I'm just using that as my multiplier. Yeah, it's much more control, isn't it? So if I say 100, it's too slow. Yeah, it's much more. Okay, cool. 50 is too much. I can rotate my rocket much more efficiently, yeah? Okay, so now we are able to move the rocket in a much better way, so this is good. I think our main thrust also should be driven by a frame independent movement. So what I'm going to do is I'm just going to use the T frame. Okay, cool. So we have done a lot of things. We took our rocket, we made our rocket move up and rotate left and right. I want to take this launch pad. I'm going to duplicate it, call it my space station. Yeah. So this is the target point. I'm just going to move that. I'm just going to make it a bit more bigger. Okay. Okay, so what I want is, let me create another material. So let me take this, duplicate it. I'm just going to call it space station material. Yeah, so okay, I don't want this actually speaking. Let me just give the launch pad material itself to my space station. Okay, what I want is, I want the rocket, okay, and also let me move it on the y-axis just to give some feel of interest. Okay, now I'm going to move the rocket and see whether I'm able to land my rocket in the space station. Yeah. Okay, fine. Okay, I'm able to land on my space station, so this is good. Okay, so what I want to do next is, I want to ensure that I fly my rocket without getting hit anywhere, and I have to successfully launch here. So what I'm going to do is, I'm going to create a few obstacles. So let me duplicate and call this as my obstacle. I'm just going to move it, scale it, okay. I'm going to give a danger color. Okay, so Okay, so I have my obstacle. I'm just going to move it high a bit, and I have to ensure that my rocket doesn't get hit. I'm going to duplicate this. Okay, I'm just going to rotate. I'm going to say, yeah, I'm going to say scale 1. Okay. You cannot go and bang yourself. I'm going to similarly duplicate it. I'm just doing a sort of set design right now. Okay. Okay, but let me call this as BG. Okay, let's create a BG material. Let's use the same one, maybe. Okay, let me go to a top view. Okay, so I have a base set design, very primitive types. I've not spent too much time, doing the set design. All I did is just set up a few base objects. Now what we need is, I want the rocket to fly through without hitting any of this, and I want the rocket to successfully be landed on my space station. So how am I going to do that? So let me just tag each of these objects so that I can refer them in the code. So I'm just going to call this as finish. These are some of the predefined tags supplied by Unity itself. Now what I want is I want my rocket to be maneuvered good enough so that I don't get bagged into any of the objects, be it the obstacles or be it the ground plane. And I want that to be successfully landed into my space station. So how am I going to do it? So what I'm going to do is I have none of my objects tagged. Okay, that is good. And my space station is tagged as finish, which is good. And I want to tag my launch pad as something like, let's say, friendly. Yeah, so I'm just going to call it friendly. So friendly, finish, and none of them are tagged actually. So let me go back to the code. Now what I want to do is to access these tags. Yeah, so how am I going to access the tags is nothing but Okay, by the way, so before we go into the tags, now I need the Unity engine to understand, whether my rocket is getting banged into any of these objects. Yeah, so because this particular thing has an object called rigid body, my rocket itself for that matter, yeah, this rigid body, and if you see all the other objects naturally comes with something called colliders. Yeah, so if I remove this collider, now when the rocket goes and bangs, it doesn't recognize that it collided with something. So that's what this collider object helps you to recognize. So what I'm going to do now is go to the code, and Unity provides a method called collision enter. So this is the default method, and if you see, the collision object is the object that our rocket is getting collided with. So now what I'm going to do is, if my collision objects dot game object, so I'm asking, okay, give me the game object that I'm colliding with, and what is its tag, and if it is finish, I'm going to say reached space station successfully. Yeah, yes, okay, or else if I have another, I'm going to say I have my launch pad which is flagged as space friendly tag, so I'm just going to say I will add my behaviors later. So friendly object, no worries. Okay, yes, I'm going to say okay, major hit, rocket collapsing. Okay, let's see whether our messages gets printed properly. Okay, I think I didn't do this. I'm going to play the game. Shift to console, clear all. Yeah, I'm thrusting, and if you see the message, because I'm on this, it's saying this. Major hit, rocket collapsing. Yeah, reached space station successfully. Okay, rocket collapsing. Okay, so our code works. So far that's fine. So now what we want, but our rocket is right now lifeless. So let's add some sound and particles and stuff like that. So let's get in. How am I going to add a sound? So what I'm going to do is, let me add some sound systems that I already have. Okay, so let me import these. These are available in the public domain. You can import them, download them. Okay, let me add and another component called audio source. Okay, I've added. So that has got number of properties. I'm just going to control playing a clip through my code and not on start of this particular object. So I'm just going to uncheck it. I have 3 clips, so what I'm going to do is go back to my Visual Studio, add 3 more serializable properties. You know what the serializable fields do. So I'm just going to say audio clip. I'm going to say main engine sound effects. Okay, so I'm just going to copy. Okay, I'm just going to call this one as death sound effects, and I'm going to call this one success sound effects. Okay, so now just like now I need to play an audio, I need an audio source object. Okay, which means I need to access this, which means I need to do the same thing what I did for my rigid body. So I'm going to have audio source. Okay, so let me say a src equal get component. Okay, I'm going to say audio source. Okay, now I can do this. So whenever I thrust, I want my audio to play. So src.play one shot, and if you see, this takes an audio clip. So the audio clip that I want to play when I'm thrusting is main engine sound effects. Okay, and similarly, if I copy this, if I go to my collision, whenever I reach my destination, what thing I want to play my success sound effect. Okay, if I hit anything else, I want to play my death sound effects. Okay, now if you see, just to recap, I have 3 audio clips and I'm playing those audio clips at different trigger points. One while thrusting the engine, the other one on reaching the destination successfully, and the other one while hitting it. But what I have not done is, while I have assigned 3 new serialized properties, but the clips have not been assigned, so I need to assign the clips to the respective properties. So I'm just dragging and dropping the death sound effects and the main engine sound effects, and then sorry, I think I made a mistake. I want the jingle to be on the success, and I want my death sequence to have my death should be on the death, my jingle is here, and my main engine to be the thrust. Okay, so let's see. Okay, so the problem is the thrusting engine kept on playing, and it's a long clip, and that's why I'm not able to hear the other sound. So what I need to do is, if not src is playing, play this, else asrc dot stop. Sorry. Okay, let's see what happens now. Okay, my death is coming and my success is there. Okay, so my audios are playing fine. Let's do some particles too. Whenever I fly my engine, I want some particles to fly through. And a particle system is a system of its own. If you see here, it generates objects into all axes, and there are a whole list of properties that you can control. It's a subject of its own, and I'm not going to talk about it right now. We'll do it in a separate dedicated video for this. So I'm just going to delete. I've already pre-built a couple of packages, the particle system. So I'm just going to again go back for particle sound effects. Okay, I'm just going to add it to my project. So it's going to ask me, do I want to import all of them? Yes. So these are nothing but specific packages built using reusable components that are built using Unity again. So I have 3 packages: one for explosion, one for success, and one for thrusting. That's what I'm going to do. So I'm just going to add all these 3 as a sub object to my rocket. You see already different particles flowing through. Now what I need is very similar to what I have done for my sound effects. So I just go back. Okay. This time I'm going to build a particle system. I'm going to say my main engine particle effects. Okay, my death sound effects and my success particle effects. So now I'll go back to my Unity engine, and if I choose my rocket, I see 3 more, but none of them are assigned. Now I need to assign my sub objects to those properties. So my success particles. Okay, because my property is getting changed, I'm just going to lock my property window. Okay, so that when I select a different object, the property window continues to show for rocket. So my success particle should go into my success PFX. My explosion will go into the death, and my rocket jet will go into my main engine particle effects. Yeah, so now I've created the properties, I've assigned the particle packages. Now I go back, and now all I need to do is, while thrusting, I just need to play it. So all I need to do is main engine while thrusting dot play. Simple. When I finished, I want to say my success particle effects dot play. Okay, and my death particle effects to be played when I hit or collide with some of my collision objects that I'm not supposed to. So let's see what happens. I'm just going to go play mode. Ah, cool. Okay. If you see, the objects are not in the root property, so I'm just going to select all of them, going to transform, and then reset. Okay, run. Okay, yeah, that's my death. My success particles are still coming from somewhere, so let me go and reset. See, I made a mistake because my rocket object is still locked. I was resetting that instead of resetting the sub object, so I need to unlock it. So now all my properties are selected, so I need to go to transform and then reset. Now when I play, things should be fine. Okay, that's cool. So what we have done so far is we created a primitive rocket. We made the rocket to move around, move up, rotate, fly through, avoid obstacles, and reach our destination. So this is a simple core game mechanics that we have just built. So what we are going to do next is have something a bit more complicated. We are going to make a level 2 design. So I'm just going to rename this design called level 1. Okay. The very important aspect in Unity is something called prefabbing. Prefabbing is nothing but you build an object and then you prefab it so that you can reuse it in other scenes. For example, I want my obstacle to be prefabbed. I want my space station to be prefabbed, my rocket to be prefabbed, my terrain to be prefabbed, so is my launch pad, my direction light, okay, my background, everything. So now when I build a new level and when I try to reuse these objects, all the properties and all the controllers that I have assigned, all the code that I have written will automatically flow through the other scene. So that's the main benefit. Yeah. So what I'm going to do right now is, and also you see that, if it's a prefabbed element that you're using in a particular scene, it appears in a blue. If it appears in a gray, which means it is a local object and it is customized, to that specific scene. So now I have a level 1. Now what I'm going to do is, I'm going to duplicate this level and call it level 2. Now what I'm going to do in a level 2 is, I'm going to do something bit more complex and make it difficult for the player to maneuver the rocket and reach the space station successfully. So I want to make the level a bit more difficult. So what I'm going to do is, let's first of all say, let me go to the level 2. Okay, I'm in level 2 if you see, but because I copied, everything looks the same. So what I'm going to do is, I'm just going to move this the top. Okay, and this is the obstacle. Okay, let me add a light to it. Okay, just to make it a bit more interesting, let me add a spotlight. It's looking at some different angle, so I'm just going to increase the range. I'm going to increase the intensity. Let me create a light. Let me create a spotlight. Let me reset its position. Is going to rotate 90 degrees. Okay, let me make it a sub-object, the obstacle. I want to switch off the directional light. So let me go to lighting and I want the intensity to be, box to be less. Okay, so now my spotlight. Okay, increase my range. And similarly duplicate one more, just adding a bit more interest to the scene here. So I want intensity. Okay, so let me move this obstacle here, scale it a bit more longer on the Y. So let's move the space station somewhere on the higher side. Okay. Now what I want is just to make this level a bit more interesting. I want this object to be moving, so how are we going to do that? So let's see that in level 2, but before that let me switch to level 1, and then I will show you how you can navigate between multiple levels. Yeah, so one thing that you need to do is you need to go to a build settings, add your scenes to it. So if you see here, I've added my level 1. Now I need to add my level 2 as well, and of course the levels has an index of zeros and ones, start with zeros and ones. So I've done this. I'm doing it for a WebGL for now, for a PC, and of course you can publish these for various platforms. We'll talk about these things later. Let me just close this. Let me save it. Let me go to the code again. So what I need is, besides using the Unity engine package, I'm just going to use one specific package called scene management. Yeah, so this is the one that helps us to navigate between one to other. So what I need is when I reached this successfully, I want my scene to go to the next scene. So I'm going to say load scene. Okay. Level 1. Okay. Anytime I die, I'm just going to call it load my scene 0. Yep. So let's see whether I'm able to switch. Play. So our scene shifting is way too abrupt and it's not having a smooth sail. So what I'm going to do is I'm just use a method called invoke Invoke is more like a coroutines. It's a callback function after a specified period of time. So if you see, invoke has got a method that you need to have a callback, and after how many seconds, this is in seconds, when the callback method to be performed. So what I'm going to do is I'm going to refactor this into a new method and call this as load next scene. Okay, and I'm going to refactor this piece of code as load first scene. Okay, so I have two methods being refactored. So I'm going to call load next scene after 2 seconds. Okay, so this is the string, so I need to do this. Next, I need to say invoke load first scene after 2 seconds. Yep. Now when I run the app, failed. Okay. I think my code refactoring screwed me up by putting this static automatically. And that's why I'm getting an error message called failed to call a static function. So let me run again. Yes. After a few seconds, I'm shifted to the next scene and I'm back again. Okay. So let's continue with level 2 design. Okay, so let me save this. So my level 2, where is it? Yes. Okay. Okay. So my space station is here, that is tagged with finish. My launch pad is friendly, so no worries, and everything else is untagged, so that is okay. My rocket is fine. Okay, now the next thing that we want to do is in this level, I want this to move automatically. So for example, the way I'm going to do is, so this is the obstacle object. So let's say this is starting position. Let me just round it off to 7. Yeah, so this is the starting position and I want this obstacle to move from 17 to 20. Okay, so this is 7 is my starting position and 20 is the end position, and I want to oscillate this particular barrier between these two endpoints. How am I going to do this? Okay, so let me set it back to its starting position 7. Okay, and 7 to 18. Okay, which means I have offset point by 11 points. Okay, so how I will do, so let's choose the obstacle and I want to add a component which is a new script that I want to add. So let's say oscillator. Okay, new script. Yes, I want to create and add to my current object. Okay, so if you see here, my oscillator script is added. Okay, so Double click on that, I'm taken to my oscillator and my rocket controller is still here. Okay, so my oscillator is blank and this is tagged to my obstacle object, this particular object. And if you see, this is not in blue, which means this is a local instance in this particular game scene. Okay, now what we need to do is move this object up and down. Okay, sorry, left to right. So how we will do, let's say I want to add two serializable properties. Okay, I want to say vector 3. Okay, I want to say of course I need a starting position, isn't it? So I call it starting position. Okay, I don't need, sorry, so I need a starting position, but I need a serialized field three moment vector. Let me call it that way. Okay, I want to say serialized field. I will explain what I'm trying to do here. Moment factor. Okay, of course I want to get a starting position of the current object. So starting position equals transform dot position, yeah, which is nothing but I'm going to get 7, 15, let me make it 7, 15 and 0. So that's what the starting position should have. Now what I want is, if I see these two things, I have created a serialized properties. So my movement vector is come and my movement factor is also here. Now what we want is, when I want the movement vector offset by 11 points, because from 7 we want to go to 18. From 7, sorry, I think, yeah, we said let's say 7 to 19. Okay, that's 12 points. Okay, so I want the x to move by 12 when the movement factor is 1. I will explain what I'm trying to say. Okay, so let's say this, what we want is, we want vector 3 offset equal offset. Okay, 3 equals offset. We want offset, we want offset moment vector into moment factor. That's what we want to move, right? So I'll explain what that's trying to do, and then I'm going to say transform dot position equals my starting position plus offset. Let's see what happens. Okay, so okay, what I need is, if I take my obstacle object, okay, now I have a moment factor of 0. So let's say I want to move this by 12, because we said we wanted, and if I say 1, see where the rocket have gone. I think I made a mistake. Let me say I want to give this a value, sorry, go to my oscillator script. I want the moment factor to be further constrained by range of 0, 1. So when I go back, you see now it's changed as an indicator. Okay, so let me run the app. Okay, now when I move, can you see this is moving in x-axis, given that this is the start position. Okay, so I want the starting position to be 7, correct? And I want this to the maximum. I want this to reach by additional 12 points, which is 19. So I'm just going to change to 12, and what it means is I want my obstacle to oscillate between a position of 7 to a position of 12. When the value is 0, I want this to be in a position of 0, but when it reaches the 1, I want the oscillation to be at 12, and that's what it's doing. If I want to oscillate in multiple axes, let's say my value is 15 and I want to go twice, see where it disappeared. Okay, do you see the value of y moving? And let's say I want z to be moved by 10. Okay. I want to reduce, right? So I want to reduce the -5. Okay, let's play. Can you see my oscillation is going up and down? Yeah, so I can say this 12 and -5, which means my system is going to go like this. Okay, isn't it fun? But what we want is we want our oscillation to be automatic. You don't want somebody to control this. We want that oscillation to happen automatically and the obstacle to move and make it difficult for the rocket to go down. Yeah, so how we are going to do that? Let's see that. So I'm going to just give the same values. So equals, okay, that's fine. Okay, so just making it some default values. Okay, so now how we are going to move it automatically. So now how we are going to move it automatically. Let's see. So what we need to do is, this part of the code is perfectly fine. What we need is, we want this movement factor to move automatically, correct? So we want the movement factor to be calculated. Okay, how are we going to calculate? So I just want you to introduce two specific concepts. Maths play a critical role when it comes to the game design, especially the oscillation. There are a couple of key topics that you must definitely be aware. Tau, I hope you would have heard in your 12th maths. This is all about, how the how many radians makes a particular circles and stuff like that. I just want to take you to one specific aspects of it, specifically in the maths part. Tau is a constant circle. I think this is the proposal. Yes, yeah. Okay, so in the context of math, if you see this particular diagram, what it says is, if you take any circle, this is a 1 radian. The distance between the origin and end point is 1 radian. If you take this particular distance, make it a vertical angle, but align it to the arc of the circle, you get 1 radian. And if you just keep moving it, what we get is, to make a full circle, we need a 6.28 radians. In a traditional sense, we call it 2 pi. Yeah, that's what this tau is all about. This is one. The second one that you need to be very familiar is about the sine. Okay, so if you check here, any sine wave, will oscillate between, if you see here, between value 1, which is the peak value, and the lowest value is -1. So wave is -1. Why the sine is required? This is particularly used to calculate any harmonic oscillators. What is harmonic oscillators? A smooth animation when any item oscillates. For example, when I do this, it's not smooth. It's getting jerky and stuff like that. Yeah. So just to be, it's not smooth. When I come here, we want this to be a pretty smooth. So that's where we use a sine wave, and for the sine calculation, we need a tau. So that's where these two specific parameters comes in. Let's go back to the code, and so we said float tau equals mathf dot pi. Okay, so tau is nothing but 2 pi, so we got that bit sorted. Okay, now we need to calculate the sine. Okay, so float raw sine. Okay, raw sine is mathf dot sine. Okay, we need to calculate the cycle. Okay, so what I'm going to do is, before that, let me say float cycle is time dot time by 2. Okay, what I'm doing is I'm just taking a time it takes to complete one cycle, which is moving from left to right and then right to left. No, it takes two cycles in a given play time, to calculate the number of cycles. So what I need is, I want this tau times cycle will give you a value of raw sine. Now what we need to do is, now as we saw, the raw sine oscillates between a value of 1 and -1, whereas we need a value between 0 and 1. Yeah, so what I'm going to do is, I'm going to take one temp variable. I'm going to take my raw sine by 2f. Okay, and I'm going to add plus 0.5. Okay, sorry. Okay, so this is my calculation. Let's see what happens. Do you see my moment factor is already oscillating between 0 and 1, and see how smooth it is. Yeah. Now if I say -5, can you see my obstacle is oscillating? Perfect. I think our code is brilliant. So let me run again. Now my it's too difficult, so let me just make it 0, or maybe I will say 2 in the other axis. Yeah, instead of coming down, I made it to make it easy. Destroying the object and resetting to scene 1 or the first scene. Okay. You get the idea. Yeah. So that's pretty much what I have for the day, just to show you some of the core game mechanics, and I hope you enjoyed it. So just to have a quick recap, in scene 1, we built some primitives, we built the origin, we built some obstacles, we made the rocket to go from one point to another, we tagged, we wrote a code, to play the audios. We try to access the rigid body to control the thrust and the rotations and stuff like that. We also had some particle systems to emit some behaviors. We did the rotation through this logic. Then we dealt with collisions, how you recognize the collision events, what object you're colliding and initiating different behaviors and stuff like that. In scene 2, we built very similar, but we made the level a bit more difficult by introducing a behavior not to the rocket this time, but to the barriers, the obstacles. So we had access the starting position of the barrier, and then we moved the barrier by an offset, so we gave some default values here, and then we did the tau and rho sign to calculate the floats. So that's pretty much, one thing before I wrap up this session, I want you to be aware of this. This particular code, is a junk. It's not maintainable. It's way too complex, and it's doing too many things. I always believe in if you want to write a maintainable software, you need to. This piece of code is pretty complex according to me, and if you need to write a maintainable software, you need to definitely follow a single rule of responsibility as a coding principle, no exception. I'm just going to refactor this code to make it simple and each function to do just one small little thing. Yeah, so let's do this. So these are all okay. In start, I'm not doing too many things, but for accessing, which is okay. But if you see in the update, I'm doing so many things out here. Yeah, if you see, it's stopping the game mechanics before I take some control. So that part of the code is okay. And this particular thing is for thrusting, and I'm doing some logic out here. Yeah. So if I take this piece of code, this is all about thrusting, isn't it? Yeah. This is all about thrusting. So I'm just going to refactor this, say, extract the method and call it thrust. Okay, and if you see all of this code, this is all about rotation. Yeah, I'm going to again refactor and say rotate. Isn't it much simpler now? Can I refactor the rotate any further? I don't think so. It's not doing much, so this part is fine. Can I refactor the thrust? Anything? Not really, isn't it? There is not much happening. So we can, if you want to control the audio playing a bit differently, but let's leave it for now. On collision, enter. Okay, again, there are so many ifs and else, and each of the ifs and else is doing so many things. Now, what we want here is we want this entire thing to refactor to say, correct? Initiate success. That's all. Yeah. So my initiate success will play the success sound effects, success particle effects, and then it will load my next scene. Yeah, that's pretty much. And similarly, if I see here, this is all about the death. So I'm just going to refactor this piece of code. I'm going to call it initiate death sequence. Just let me call it a bit more. Okay, that's cool. Now my code is a bit more neat. So on update, I'm just calling thrust and rotate. I'm taking control of the game physics. I'm doing thrust and rotate, and I release the control back to the physics engine. The rotate is doing just one thing. It's all about rotating depending on the key I press. Thrusting, just doing thrusting and pushing the rocket move up based on the key that I press. And of course, playing some particle effects and the sound effects. My collision, when I finish, it's just initiating the success sequence. And similarly, my death sequence when I collide with some danger objects. So my initiate death sequence is nothing but playing my death sound effects, my particle effects, and then reset my game. And similarly, my success scene take you to the next scene, and it plays the success sound effects and the particle effects. How simple it looks. That's it, guys. What we have seen today is only a tip of the iceberg, showing you some of the core game mechanics, but we need a lot more detailed understanding of an end-to-end game dev pipeline, that includes story outlining, character modeling and texturing, of course, the environment design, the game level designs, the non-playing characters, AI and multiplayer modes, some of the game analytics, and of course the monetization, that comes into the play. So there is lots more to learn. Stay tuned, and I'll see you with another interesting video next time. Till then, see you. Bye bye.